Hello guys, how are you doing? Yes, this is your Dr. Vantar Shiva. In this video, we are going to cover the previous year NEET questions of the chapter Work, Energy and Power. This is the part 1 of such sessions. We'll make 3-4 such videos. Okay, so in the previous video, we have covered the concepts of work, energy and power. If you have not watched it, you can watch it using the link given below in the description. Okay, let us get started. So the first one is a particle moves so that its position vector is given by r is equal to cos omega t x cap plus sin omega t y cap, where omega is a constant. Okay, which of the following is true? So here he has given that velocity is perpendicular to r, acceleration is directed towards the origin, velocity perpendicular to r, acceleration is directed away from the origin. So both of them are almost same, but acceleration is towards origin, away from the origin. Now velocity and acceleration are perpendicular to each other, perpendicular to r both. Next, velocity and acceleration both are parallel to r. That's what is the question now. Let us have a look at this. Generally, if you take this is a position vector, if you consider the x coordinate of a position vector, that is a cos omega t, y coordinate of it is a sin omega t. Okay, if you just differentiate it, you'll get vx. That is nothing but cos omega t. Differentiation is what? Minus sin omega t, and you have to differentiate this omega t again, you'll get 1 omega extra. What about vy? Vy is nothing but differentiation of this is nothing but cos omega t. Omega t should be differentiated once again, you'll get omega again. Now let me rewrite this. So minus omega sin omega t. Next, this is nothing but omega cos omega t. What about acceleration? Acceleration is equal to, if you differentiate this once again, you get sin omega t. Differentiation is cos omega t. If you differentiate this omega t again, you get omega. Already one minus omega is there, so minus omega square cos omega t. What about ay? So it's nothing but if you differentiate this once again, you get sin omega t under 2 minus sin omega t. Okay, you'll get 1 omega extra from this differentiation, and then already 1 omega is there, so omega square sin omega t. All right, so now if you look at this, if you write velocity vector is nothing but minus omega sin omega t x cap, okay, plus omega cos omega t y cap. What about a vector? That is nothing but minus omega square cos omega t x cap. Again, this also having 1 minus. So if I can take 1 minus omega square common, it will be like cos omega t x cap plus sin omega t y cap. Is it nothing but r vector, position vector actually. So basically, look at this. These are the expressions for position vector, velocity vector, and acceleration vector. Okay, very good. Now if you look at this x coordinate and y coordinate, if you just take them and square them off and add them, what will you get? Cos square omega t plus sin square omega t. All right, so cos square omega t plus sin square omega t is 1, no? So this is the equation of a circle. X square plus y square is equal to r square, where radius is actually 1. So essentially the particle is performing the circular motion. This is the trajectory of the particle. All right, very good. Now generally, if the particle is actually in circular motion, this its position vector is always directed outwards, if suppose it is having both of them are positive. All right, so if you look at this acceleration vector is getting minus omega square times r vector. If position vector is going radially outward, acceleration should be radially inward. So basically acceleration is directed towards the origin. Out of all these options, option A is correct. Of course, if you want to check it whether velocity is perpendicular to r vector or not, you can take v bar dot r vector. Let us look at this. Minus omega sin omega t into cos omega t, again plus omega cos omega t sin omega t. I am just taking the x components of v vector and r vector. I am just trying to find out the dot product between them. So both of them are same actually, minus omega sin omega t cos omega t plus omega cos omega t sin omega t. So both of them are actually same. So it is 0. It is nothing but if dot product between two vectors is equal to 0 means both the vectors should be perpendicular to each other. So obviously option E is correct. Alright, next. If vectors A and B are functions of time, then the values of t at which they are orthogonal to each other is. So basically he has given that they are orthogonal to each other. What is the meaning of orthogonal to each other? They are perpendicular to each other. Perpendicular to each other, just now we have discussed a bar dot b bar should be equal to 0. Okay, if you find out that, just take the x components of a and b, multiply them, isn't it? Plus take y components of a and b, multiply them. Alright, and now that's supposed to be equal to 0. So it's nothing but cos a cos b plus sin a sin b. It is nothing but a cos of a minus b. Alright, that should be equal to 0. Cos omega t minus omega t by 2 is nothing but omega t by 2. 1 minus half is equal to 0. Very good. So cos of something is equal to 0. That what about this angle now? Cos pi by 2 or cos 90. Okay, omega by 2 is equal to pi by 2. This 2 gets cancelled. So at the time supposed to be pi by omega. Which option is correct, Amma? A. Alright, next one. If a vector is given is perpendicular to the vector, this one, okay, what then the value of alpha is? Actually here you have to be very careful. Just to confuse you, he has given that j cap term first, next 4a cap. So you have to be very careful, otherwise if you'll get the answer as this. Let us check it. Okay, so now perpendicular, two vectors are perpendicular to each other. That means what? Their dot product is supposed to be 0. So take x component of first vector and x component of second vector. So 2 into minus 4 plus 3 into plus 4 and then 8 into alpha is equal to 0. Okay, 2 minus 2 4s are 8, 3 4s are 12 plus 8 alpha is equal to 0. 12 minus 8, 4. So 8 alpha is equal to minus 4. 8 ones are, 4 ones are, 4 twos are here. So alpha is equal to minus 1 by 2. Okay, option B. Exactly, if you take this as by mistake, if you take this as I cap and j cap, you will get this answer. That is wrong. Please be very careful while attempting the questions of NEET. The vector sum of two forces is perpendicular to their vector differences. In that case, the forces are what? So for let us take F1, F2 are two forces. Very good. Now you are finding the sum of vector sum of two forces is perpendicular. That means what? If you just take F1 vector, F2 vector, is it the sum? Yes. So that's supposed to be perpendicular to their differences as well. Okay. So what does it mean generally? Suppose if you have A is perpendicular to B, then A dot B is supposed to be 0. Just we can find that out. F1 plus F2 dot F1 minus F2 supposed to be 0. Now let us split it up. F1 dot F2. I am applying this F1 dot to both of them first. F1 dot F1 plus F1 dot, actually it's a minus is there, so let me take a minus here. F1 dot F2. Next let me apply this F2 dot F1 here. Next minus F2 bar dot F2 bar, supposed to be 0. So can I write this as A bar dot A bar is nothing but A square, na? Like that, F1 square, and this is A bar dot B bar should be equal to B bar dot A bar. So you are getting both of them are, magnitude wise both of them are same, and one minus sign is extra there, so you can cancel them off. Minus F1 square is equal to 0. What does that mean? F1 magnitude whole square is equal to F2 magnitude whole square. So that means F1 magnitude should be is equal to F2 magnitude. That means what? Which option is correct? The forces are equal to each other in magnitude. So option B is correct. Clear na? You can look at other options. It doesn't match. Next, the position vector of a particle is this. The velocity of a particle is, so basically we have the first problem is of a similar kind. One extra a is there here, that's it. Okay, so now you can say that the velocity vector is directed towards the origin. That's what he has given. Now generally if you take this one, it's also a circle whose radius is actually a, isn't it? So now the velocity vector is towards the origin. No, that is actually wrong. So particle will be moving in this direction, it will always be tangential here. Next, directed away from the origin. Velocity vector is directed away from the origin. So that is actually position vector. Even if you find out also, let us find out what will you get. Velocity v is equal to a cos omega t I cap. Sorry, you have to differentiate, no? Sorry. Just a minute. A is already constant. If you differentiate cos omega t, you get minus sin omega t. If you differentiate this omega t, you get one omega extra, I cap, plus a is already there. Sin omega t differentiation is cos omega t, and one omega extra will be coming on j cap. Alright, if you find out the dot product between them, you will get obviously 0. That means what? R and v are perpendicular to each other. Okay, so velocity is always perpendicular to each other, position vector. Okay, that's correct. Next one, the angle between two vectors a and b will be, so for finding out the angle, we know cos theta is equal to dot product between a and b divided by the magnitude of a and the magnitude of b. How do you find that? Take x components and multiply them, 9, plus take y components and multiply them, 16, take z components and multiply them, minus 5 5 is 25, divided by root of x component square, y component square plus z component square, and then root of x component square plus y component square plus z component square. I don't have to find that because numerator itself is becoming 0. 9 plus 16, 25. 25 minus 25 is equal to 0. Alright, so cos of an angle is equal to 0. That angle is supposed to be 90 out of these options, isn't it? Yes. Now let us start with the notions of work and kinetic energy. This is the application of the work energy theorem. Okay. Yes. So now consider a drop of rainwater having a mass of 1 gram. Let us say this is a raindrop of mass 1 gram. 1 gram can be written as 1 into 10 power minus 3 kg. Sorry, kg, falling from a height of 1 kilometer. It is falling 1 kilometer. Okay, it hits the ground with a speed of 50 meter per second. When it hits, the final velocity is supposed to be 50 meter per second. Take g as a constant value. G is equal to 10 meter per second square. Alright, so now the question is what is the work done by the gravitational force and as well as the resistive force of air. So first of all, let us this is the gravitational force. Let me take it as mg. So generally the work done by the gravitational force, any force actually is a force or displacement. Mg is the force and displacement is h, and the angle between them, both of them are actually going directed towards down only. So that's why cos 0 is 1. That's why I'm not worrying about it. So what is the mass of it? 1 into 10 power minus 3. What is the g value? 10. What is the height value? 1 kilometer. 10 power 3. This 10 power 3, this 10 power 3 gets cancelled. That is equal to 10 joules. Alright, so option C is correct. Let us also find out how do we find this work done by resistive force of air. So resistive force of air is actually, it should be definitely opposing this motion. So the force will be acting in this direction for sure. So work done, we need to use, we don't know the amount of this air friction force or air resistive force. So what we do is we try to apply work energy theorem here. What is work energy theorem? Work done by all forces. So supposed to be changing the kinetic energy of the particle. Initially the rain is dropping. Okay, it's just dropping. Nobody is actually applying any force there. No acceleration as such. So initially velocity is 0. Final velocity is this. So now if you find half mv square is the final kinetic energy, half mu square is the initial kinetic energy, half m into what is mass here? Mass is the, I mean I can take m common, that is 1 into 10 power minus 3 into v square is nothing but 2500, alright, 50 whole square, minus u is 0 anyway, forget about that. Next, work done by all the forces. There are only two forces here. One is work done by gravity, other one is work done by air friction or air resistive force. Work done by, let us just find out this one first. 1 into 10 power 1 by 2 into 10 power minus 3 into 2500. 2500 into 2500 into 10 power minus 3, can I write as 2.5? So half into half and 2.5 multiplied, you get 1.25. Okay, so work done by air resistance or resistive force of air is nothing but 1.25 minus work done by gravity. Work done by gravity is how much, amma? 10 joules. So 1.25 minus 10 is nothing but minus 8.75 joules. This is the correct answer. Clear? Yes. A particle of mass 10 grams moves along a circle of radius r, let us say. Okay, that r value is 6.4 into 10 power minus 2 meters. So it is nothing but 10 into 10 power minus 3 kg. I am trying to convert everything into SI units with a constant tangential acceleration. So tangential acceleration is a constant. Okay, what is the magnitude of this acceleration? What is this magnitude of it? If the kinetic energy of the particle becomes 8 into 10 power becomes equal to 10 power minus 4 joules by end of the second revolution after the beginning of the motion. So basically in 2 revolutions it will cover a distance of how much? 2 pi r is in one revolution, so 2 times means it will be 4 pi r. Okay, now what is the work done? Work done by all the forces here. Work done will be by two kinds of forces here. One is tangential force, other one is centripetal force. So work done by centripetal force is always 0 because the angle between centripetal force and displacement will always be 90 degrees. So work done by tangential force will only be left, that is equal to change in its kinetic energy. Okay, what is the work done by this tangential force? That is mass times acceleration into displacement, that is equal to change in kinetic energy. So what is when change in kinetic energy is this much now, that is 8 into 10 power minus 4 joules. So what is the mass here? 10 into 10 power minus 3. What is the acceleration? That is what you need to find. What is the displacement? 4 pi times r is nothing but 6.4 into 10 power minus 2 is equal to 8 into 10 power minus 4. If you calculate all this, you will get answer as 0.1 meter per second square, near to this. Okay, so yes, that's it. Next question. A bullet of mass 10 grams. 10 grams means 10 into 10 power minus 3 kg. Leaves a rifle at an initial velocity of 1000 meter per second. Initial velocity is 1000, and strikes the earth at the same level, okay, with a velocity of 500 meter per second. Okay, the work done in joule for overcoming the resistance of air will be. So basically, what is the work done by air resistance is nothing but so here, are there any other force acting on it? No, there is only one force. Okay, so that can be the work done by all the forces is nothing but half into m v square minus u square according to work energy theorem. Okay, what is the mass here? 10 into 10 power minus 3. Very good. So v square is nothing but 500 whole square. Okay, 500 whole square means what, amma? 25 into 10 power 4 minus u square. 1000 means 1000 means 10 power 6 already, isn't it? I mean square. So now you're supposed to get a half into 10 power minus 3 into 10 power minus 10 power 1 is nothing but 10 power minus 2. Okay, so here can we write it as can we take 25 minus 100 into 10 power 4, isn't it? Yes. So it is nothing but 25 minus 100, 75 minus 75 by 2 into 10 power minus 2 into 10 power 4. Will it become 10 square? Yes. 75 by 2 is nothing but 37.5. 37.5 into 10 square is nothing but 3750. Okay, that is the work done. All right. Yes. Next one. Next one is what? A particle moves from a point to another point. This when a force of 4 I cap plus 3 j cap newtons is applied, how much work has been done by this force? That is the question. Now the work done, is it a constant force? Yes. So therefore I can use this as the formula, F bar dot S bar. Now what is the force? This is the force. First of all I need to find displacement. So these are the position vector of the particle. So that is nothing but r2 vector minus r1 vector. So it is nothing but 4 j cap minus 5 j cap. Can I say it as a minus j cap? Yes. So it is a plus 2 I cap. Next plus 3 k cap. Alright, that is your displacement vector. So you just have to find the dot product between this force and this this displacement. Okay, so 4 I cap plus 2 I cap is nothing but 4 2s are 8. J cap component 3 into minus 1 minus 3. K cap component is not there in the force, so it is 8 minus 3 is 5. 5 joules is the answer. You have to be very careful. If you get plus 3 here, that option is also there. Okay, next one. A uniform force of 3 I cap plus j cap Newton acts on a particle of mass 2 kg. What is the mass now? 2 kg. What is the uniform force now? 3 I cap plus j cap. Hence the particle is displaced from a location this to another position this. The work done by the force on the particle is, again the same thing, just have to find work done is equal to F bar dot S bar. Now you need to find displacement vector, that is nothing but final position vector minus initial position vector. 4 I cap minus 2 I cap. 2 I cap plus 3 j cap, okay, minus k cap again, so it is going to be minus 2 k cap. All right, so the force is this much. Then what will you do? Just have to find out the dot product between the F bar and S bar. So 3 times 3 into 2 plus 1 into 3. So 3 2s are 9. Oh, sorry. 3 2s are 6 plus 1 3s are 3. So 9 joules. That is the work done. Clear now? Next. A body of mass. A body moves a distance of 10 meters. Displacement or distance, you can say 10 meters along a straight line. So straight line means the distance and displacement will be same. All right. Under the action of a 5 Newton force. Under the action of 5 Newton force in the same direction, it seems. Okay. Next, if the work done is 25 joules, work done is equal to 25 joules. Very good. Then the angle between the force and the direction of motion of the body is, so basically Fs cos theta is the work done, that is equal to 25 joules. He is asking the angle between the force and direction of motion. Direction of motion is nothing but displacement only. Yes, that's what is theta is. Now what is F? 5. What is displacement magnitude? 10. Cos theta you don't know, and 25. 5 ones are 5 fives are. Okay, now cos theta is equal to, 5 ones are 5 twos are. So cos theta is nothing but 1 by 2. So cos 60 is gonna be 1 by 2. So you can take theta will be equivalent to 60 degrees here. Next, a body is constrained to move along y direction. It is moving in this direction and is subjected to a force of this much. Okay, the work done by this force in moving the body through a distance of 10 j cap. So you are moving only 10 units along a y axis, positive y axis. What is the work done? That is the question. It is very easy question. Directly is asking that, I mean, if you find out the dot product between this displacement and this force. So the displacement doesn't have I gap and j gap. Directly multiply with 10 and 15. 15 tens are 150. That is the amount of work done in this case. Answer is here. Now, when a body moves with a constant speed along a circle, so basically the body is moving along a circle. Now there is, I mean, see, the body is moving in this along the circle, means centripetal force will always be towards the center, and its displacement at that location will be perpendicular to it. So that's why the work done by this centripetal force is always 0. There is no work done on it. That is the correct answer. Okay, let me stop it here. We'll discuss the remaining questions in the upcoming videos. Thank you very much for your watching. So see you once again in the next video. Please do not like, share and subscribe to your friends. Thank you very much once again.